Quantum decoherence armor sounds like something ripped straight out of the deepest military science labs of the future. A suit that doesn't just deflect bullets or absorb impacts, but actually blurs the wearer's physical existence at the quantum scale, making them harder to target, track, or even perceive. This is armor that works not by being stronger, thicker, or heavier, but by manipulating the most fundamental behavior of matter itself. Today, we're going to explore how quantum decoherence armor might work, why it matters, and how it could change warfare, law enforcement, privacy, and even personal survival in the far future. We'll unpack real physics, speculative engineering, and the dramatic possibilities of a world where people can flicker between states of presence, existing, not existing, and existing somewhere else entirely. To understand quantum decoherence armor, you first have to understand quantum decoherence itself. At the quantum level, particles don't behave like tiny billiard balls. They exist in a fuzz of probabilities. They can be in multiple states at once. They can interfere with themselves. They can even share information non-locally through entanglement. This is what gives us phenomena like superposition and tunneling. But the moment a quantum system interacts with its environment, heat, radiation, air molecules, photons, it collapses into a definite classical state. This collapse is called decoherence. Decoherence is why humans don't walk through walls or why we don't appear blurry across multiple positions simultaneously. In a sense, decoherence is nature forcing things to behave normally. Quantum decoherence armor flips that around. The idea behind the armor is that instead of allowing the wearer's body to interact fully with the environment, you reduce the decoherence rate around them. You create a localized field where quantum behavior persists just a little longer than normal. The result is that the person becomes partially undefined in space and time. They're still there, but not entirely. Sensors struggle to pinpoint them. Projectiles curve away or miss. Lasers lose lock. Even a direct strike might pass through a region that is not fully classical. To an observer, the wearer appears slightly shifted, like a visual echo or a glitch. The armor isn't invisibility, it's instability. So how do you make quantum instability wearable? Enter the engineering side. A quantum decoherence armor suit might be built from layered metamaterials, structures designed at the nano or even picometer scale to manipulate electromagnetic fields, phonons, and vacuum fluctuations. These materials wouldn't behave like cloth or metal. They'd be closer to programmable quantum lattices, similar to the materials used in quantum computers, only massively scaled and made resilient. The suit might integrate quantum dots, topological insulators, Bose-Einstein condensate channels, and even photonic crystals that refract incoming signals into quantum-coherent noise. The heart of the armor would be a quantum field stabilizer, a device that generates a controlled isolation field. Think of it like a bubble of partial quantum insulation. The wearer inside is still interacting with the outside world, but much less than normal. Their presence becomes a low-resolution probability cloud rather than a crisp, localized target. To the naked eye, they might appear normal until they move. When in motion, they could smear, flicker, or ripple slightly, like a hologram recalibrating. To thermal sensors, they might look like a patch of noise. To radar, they might return multiple mismatched echoes. Now imagine that applied in combat. An enemy soldier raises their weapon. They pull the trigger. The bullet or beam travels through the air toward the wearer. But at the moment of impact, the armor's decoherence field causes the probability distribution of the wearer's position to shift. The bullet might pass through a space where the armor's body isn't fully present. Or it might hit, but lose energy because the point of contact doesn't resolve perfectly. The armor doesn't rely on hardness, it relies on uncertainty. It gets even stranger when we consider quantum tunneling. In normal physics, particles occasionally tunnel through barriers due to probabilistic wave function behavior. With decoherence suppressed, the wearer might, from the perspective of an external observer, appear to skip or jump slightly through solid obstacles. Not by fully teleporting, but by taking advantage of increased tunneling probability. Imagine stepping behind a concrete pillar. With quantum decoherence armor, you might sink a few centimeters into the pillar before decoherence reasserts itself. This could be used to dodge, hide, evade, or access spaces that would otherwise be inaccessible. Let's take a moment to talk about the experience of wearing such armor. What does it feel like to be partially quantum? Surprisingly, it might feel normal. Decoherence happens so fast, on femtosecond timescales, that even delaying it a tiny bit could have a huge macroscopic effect, without the wearer sensing anything unusual. The suit's internal environment would stay classical and stable so that your own atoms and molecules don't spontaneously smear across the room. The destabilization only affects the suit's exterior and its interactions with the outside world. However, you might perceive odd sensory distortions, like slight delays in sound, strange reflections, or subtle shifts in colors, due to the way the suit manipulates electromagnetic waves. What about the tactical advantages? The list is almost overwhelming. First, near invulnerability to ballistic weapons. Traditional firearms rely on predictable physical interactions. But if the wearer's exact location has a probability distribution rather than a fixed point, not all impacts land cleanly. Even energy weapons like lasers and plasma beams rely on stable interaction points. If the surface blurs, they deposit less energy or scatter prematurely. Second, sensor evasion. Thermal cameras see noise. Night vision sees flicker. Motion detectors see inconsistent signatures. Drones struggle to lock on. Third, enhanced mobility. Tunneling, slipping through tight spaces, and moving unpredictably would make the wearer extremely hard to corner. But with all power comes weaknesses. Quantum decoherence armor would consume enormous energy. Maintaining a low decoherence environment requires constant stabilization. The quantum field generator would need superconductors, cryogenic channels, and exotic energy sources. The suit might run for minutes at full power, maybe hours at low output, but not indefinitely. Also, the armor might interfere with nearby electronics, making communication or digital targeting more difficult for allies. Imagine a battlefield where one soldier destabilizes the quantum state of a 10-meter radius. That's not subtle. There's also a fascinating limitation. The suit could make fine motor tasks extremely difficult. If your hands are flickering in micro-probabilistic oscillations, precise actions, like reloading, typing, or performing medical procedures, could become harder. The wearer might have to disable or dampen the field for certain tasks. Imagine toggling between classical mode for interaction and decoherence mode for evasion or defense. It would be like switching between solid mode and ghost mode. Let's consider how quantum decoherence armor might shape future warfare. Armies equipped with classical weapons would be obsolete. Traditional armor, tanks, and fortifications would be irrelevant. The battlefield would shift toward quantum-resistant weapons, fields that force decoherence to collapse instantly, pinning a target to a precise location. These could be stabilization beams, or coherence disruptors. Military doctrine might evolve around a dance of probability manipulation rather than brute force. Elite soldiers in quantum decoherence armor could infiltrate bases, bypassing solid walls, slipping past cameras, and neutralizing threats without direct engagement. The armor could also transform policing and security. In hostage situations or high-risk entries, officers wearing decoherence suits could approach undetectably. However, the ethical implications would be massive. Does wearing such armor violate privacy rights? Could it be used for covert surveillance? Could criminals obtain it? Governments would undoubtedly regulate the technology heavily, possibly classifying it as strategic quantum weaponry. In civilian life, a weaker, more stable version of the armor could be used for personal safety. Imagine a motorcycle jacket that reduces impact energy by creating decoherence zones around the wearer. Or rescue suits that allow workers to slip partially into rubble to find trapped survivors. Industrial environments might use decoherence dampening gear to protect employees from extreme impacts or malfunctions. Even space travel could benefit. Decoherence fields might reduce radiation interactions, protecting astronauts from cosmic rays. Now let's talk about the wildest future: advanced versions of the armor integrating quantum entanglement. Entangled decoherence suits could share positional probability distributions. Two soldiers could partially overlap state information, allowing synchronized movement or shared perception. Entire squads could operate as a distributed quantum state, each member's uncertainty reinforcing the others. In extreme cases, they might appear as a swarm of probability clones, confusing sensors and enemies alike. And then there's the idea of full-phase decoherence armor, a suit that, when activated, lets the wearer step into a more exotic version of reality. Not a different universe, but a less classical version of this one. In such a state, matter behaves differently. Subatomic interactions dominate. Objects don't feel quite solid. The wearer could navigate spaces by sliding between probabilistic states, almost as if walking through a dream where physics is flexible. If humanity ever reaches this stage, quantum armor would stop being armor and become a portal to new modes of existence. Of course, there are catastrophic risks. If the suit malfunctions, the wearer could desynchronize from classical space, becoming fatally non-local. A runaway decoherence loop could erase the coherent structure of the user's biological matter, essentially dissolving them into quantum noise. An overloaded field generator could create temporary zones where physical laws fail to behave normally, causing localized disruptions. The promise of invincibility comes with the shadow of annihilation. Yet the potential impact on civilization could be transformative. The existence of quantum decoherence armor would push humanity to further understand quantum mechanics, develop safer quantum energy systems, and build advanced metamaterials. It would inspire new art, philosophy, and ethics around identity, presence, and the nature of existence. If people can shift between states of being and almost being, what does it mean to be human? Quantum decoherence armor is one of those technologies that sits at the boundary between imagination and possibility. While we're nowhere near building such suits today, the building blocks, metamaterials, quantum computing, topological matter, and superconductors are all areas of active development. Bit by bit, we're learning to tame quantum behavior. And every step we take toward controlling decoherence brings us one step closer to armor that can blur the line between reality and probability. One day, soldiers, explorers, rescue workers, astronauts, and even civilians may wear suits that make them partially untouchable, ghost-like yet real, present yet uncertain. When that day arrives, the world will have to rethink not just warfare or safety, but the fundamental nature of interaction itself. Quantum decoherence armor wouldn't just protect the body, it would challenge our understanding of what bodies even are. Hey everyone! If you enjoyed this video, make sure to hit that like button, drop a comment to share your thoughts, and subscribe so you don't miss any of our future uploads. Your support helps this channel grow. Thank you for watching.